Ça filme. Et donc, faut pas que je dise de bêtises, c'est ça?
Bah voilà, trop tard. Et bisous tout le monde là, LavaJUG, parce qu'on n'est pas des gens comme ça.
Ok, c'est parti. Donc, en fait, juste l'intro sera en français, donc profitez-en. Donc, merci à tous d'être venus, finalement un petit peu nombreux, malgré tout ce qu'on a pu dire. Donc, ce soir, on a le plaisir d'avoir Jim Melico qui nous vient de je sais pas où d'ailleurs.
Hawaï.
De Hawaï. Exprès. Pour nous parler de sécurité en Java. Donc, on remercie nos sponsors préférés, en particulier CGI, Devox France, Almeris et Braincube, qui recrutent. Donc, si vous voulez.
Almeris aussi.
Ouais, mais nous, on est plus sympa.
Ouais, mais nous, on fait venir Jim Melico.
C'est vrai.
Ah.
Merci à nos partenaires. C'est la dernière fois que je remercie l'Université d'Auvergne et l'Université Blaise Pascal. Donc, une pensée émue pour eux. Et merci à JetBrain qui nous offre les licences IntelliJ que vous pourrez gagner à la fin grâce à la super question de Jim, parce qu'a priori, il y aura une super question. Et merci à O'Reilly qui nous re-sponsorise, parce que Olivier a été négocié le sponsoring à San Francisco la semaine dernière. Et du coup, maintenant, O'Reilly nous re-sponsorise. Je vous rappelle qu'on filme tout ça quand ça marche. Enfin, faut voir. Oui.
Plutôt bien parti.
Ça marche, ça faut demander à Page. Donc les vidéos sont en live, enfin on retransmet en live et les vidéos sont disponibles sur la chaîne YouTube. Donc YouTube, LavaJUG. À Clermont, il y a plein de trucs cool, en particulier nos amis de Clermont Tech, dont nous avons des représentants ce soir. Clermont JS, il faut les encourager pour qu'ils relancent la sauce, c'est vachement bien. La Cube, ils nous préparent un Agile Tour, et Clermont RB, ils boivent des bières de temps en temps, il faut les suivre sur Twitter pour savoir ce qu'ils font. En matière de LavaJUG, donc nous on revient le 19 janvier, avec Alexis Hassler qui viendra nous parler des modules en Java 9, parce qu'a priori ça va enfin sortir, sauf s'ils reportent, mais voilà. On a une soirée React en février, on n'a pas la date exacte parce que Daniel est en pleine négociation, mais ça sera en février. Il y aura peut-être aussi un workshop derrière sur le même modèle que ce qu'on a fait avec MongoDB l'an dernier. Voilà. Donc voilà, moi j'ai fini.
Je vais faire un petit détail. Évidemment, la session ce soir est en anglais, donc si vous avez un doute ou quoi, n'hésitez pas à poser vos questions en français. On traduira, on fera pour que ce soit visuel quand même, quoi, donc n'hésitez pas. On fait les traducteurs. Voilà.
Toi surtout.
Ouais, aussi.
Voilà, donc remercie encore une dernière fois aux sponsors qui nous versent l'argent qui permet de faire venir les gens de Hawaï, tout ça. Donc CGI, Devox France, Almeris et Braincube. Donc voilà, Jim, it's up to you.
Bonsoir. I do not speak French at all. Other than a few words, I have two major flaws in my character. Number one, I'm American, which means I'm an unwashed savage barbarian. I do not speak French, forgive me. Number two, I am Sicilian in origin, which means I'm crazy. So, that being said, let's talk about Java. Whoa.
If you want to present, you have to plug that.
No, well, this is
Sure. Nope, no problem. I'll make this work.
Excellent, sorry.
No worries. I got this. I just misunderstood. I'm sorry. It is super organized. I know where every wire is. No, it's okay. It's part of the organization.
Okay.
Right. We got this.
Is it safe to display something?
We got this.
Excellent.
Okay. You see this okay? Everything good? All right, the virtue of American processed cheese. I know in France you think your cheese is good. I want to explain to you really first why American cheese is actually awesome. No, I'm just kidding. Let's move on. Let's talk about new security controls and enhancements in Java 8 and Java 9. That's what we're really here to talk about. I was joking about the whole American cheese business. Let's forget that. Forget that. I only speak English, so if you need a translation in French, please just stop me, and I'm sure one of your friends can translate. I'm very flexible. Understanding is more important than my talk, so if you need me to stop for a translation, please just ask anyone around you or ask me to stop, and I'll be happy to do so. My name is Jim Manico. I'm the author of the book Ironclad Java for Oracle Press about building secure web applications. I have been a software developer for many years. I'm kind of a friend of Oracle. I don't work for Oracle, but I've done a lot of things with Oracle, and I've been very happy with them as a business partner in different ways. I'm a volunteer for the OWASP Foundation, and I'm from Kauai in the Hawaiian chain, so aloha. You're all welcome to come visit Hawaii. Just let me know when you're at the airport. I have a place for you all to stay one at a time. This talk was originally given at Java 1 in San Francisco just a few months ago. And let's talk about first what the Java enhancement proposal is, right? One of the purposes of this talk is to show you that many controls in Java from a security point of view have happened because of the whole Java enhancement process. And so the Java community is what we say in Hawaiian, the Hawaiian language, is a ohana. It's a family. And so there is a lot of different people from Oracle, from the old Sun organization, from different members of the community all over the world that participate in the process to make Java better. And so you all have the chance to participate in that process. I know many people are sometimes frustrated with things in Java that they wish were there or they wish was fixed or they want. So if that's you, if you are unhappy with Java in some way and you have a brilliant idea to make Java better, talk is cheap. I know, I'm a talker. That's what I do. But there is the Java enhancement proposal, so you as a brilliant Java person with your ideas can submit ideas to Java and help drive change in the Java ecosystem. You know, involvement is a lot of work, and most of the attention to Java happens from people that put in the work. So again, you have an idea to make Java better, go submit a Java enhancement proposal, write it well, follow up with it, and that's the best chance of seeing change within the Java ecosystem. Because people make a lot of requests, they make a lot of suggestions, but the way to make improvements really happen or get seriously considered is to create a Java enhancement proposal, follow through with it, add to that, and that's how we make change. There's a saying, I don't know if it translates well to French, but the squeaky wheel gets the grease. Have you heard that saying before? Think of it. If you're on a bicycle or a car, which wheel gets more grease? The one that squeaks. So if you squeak about Java in the formal Java enhancement process, you're more likely to see that change happen. Now, Mike, this is a Java 1 talk. Some of my Java 1 things are still in here. Two of the individuals that I'm very impressed with are Mike Ernst and Werner Dietl. They were there at Java 1. I had a chance to meet them. They are the two gentlemen who built type annotations, a new feature in Java that I think is extremely important. We'll talk about this in this talk. Let's look at some of the Java 9 JEPs that are being worked on. Is Java 9 live yet? Not yet. What do you want? Do you want Java 9 now, or do you want them to fix some of the problems with Java 9? So Java 9, it's not just late, it's very late. But that's okay, because I think Java 9 really cares about security, right? They're doing some enhancements to the Datagram transport layer security. There's been numerous enhancements to transport layer security, TLS. There's been enhancements to OCSP Stapling, another enhancement for TLS, Transport Layer Security, the main protocol that we use for HTTPS on the websites. Let me ask you a quick question first. This is kind of a security talk. You're up. When is it okay to use HTTP in a website or web service? When is it okay to use HTTP? Say it. Seriously, when is it okay today to use HTTP? And that answer is never. I want to encourage you, never accept that HTTP is okay, because we have now Let's Encrypt. You can get a free certificate. It's going to increase your search engine optimization rank. And it's very soon, all the browsers, if you're using HTTP in your website, they're going to give errors. They're going to cross off the main lock and make it clear to every user of your cat website that this is an insecure website you should not trust, and it's going to decrease your search engine ranking. Even a cat website, you want that to be high in the ranking. So even your cat website, those cats, you know what they want? They want TLS. They want HTTPS. Meow. What's that? No, milk is come and go. TLS is forever. Confidentiality, integrity, and authenticity. So let's stop there. TLS everywhere. Yeah. So OCSP Stapling is an important protocol to revoke certificates. We also have new support for SHA-3 coming into Java 9. And finally, all SHA-1 certificates will be disabled by default in Java 9 as well. So, here's another Hawaiian word, right? I'm teaching just a little Hawaiian. Akamai. This means smart or clever. The most common use is just smart. So, Akamai, Hawaiian word smart. We want to be smart. We want to make smart choices with Java. I want to show you some of the very intelligent choices that are being made in the next version of Java. First, let's look at JEP 219, the Java Enhancement Proposal 219. So, this is about Datagram Transport Layer Security, just briefly. And so the motivation of this is it's important to support DTLS to satisfy secure transport requirements for a number of increasing Datagram compatible applications. This is RFC 4347. It lists a number of reasons why TLS is not good for certain kinds of applications. Quote, TLS is the most widely supported protocol for securing network traffic. However, TLS needs to run over a reliable transport channel, TCP. Therefore, it cannot be used to secure unreliable datagram traffic. Datagrams it's an unreliable out-of-band network traffic. An increasing number of application layer protocols have been designed to use UDP. In particular, protocols like SIP, Session Initiation Protocol. What do we use SIP for? Bingo. And electronic gaming. How important is electronic gaming? So of all the applications in the world, I think electronic gaming is the most important use of the internet, right? By far. So in many cases, the most desirable way to secure client-server applications would be to use TLS. However, the requirement for datagram semantics automatically prohibits TLS, right? Thus, a datagram compatible variant of TLS is very desirable, very important. And we see RFC 5238, 6083, and 7252 that all talk about support for DTLS, Datagram Transport Layer Security. Google, Chrome, and Firefox now support DTLS for web real-time communication. That's WebRTC. DTLS version 1 and 1.2 are supported by major TLS versions and implementations including OpenSSL, GNU TLS, and Microsoft S Channel. So just an example of one new protocol being added into Java 9. That's cool because it's about gaming. Yeah, gaming. Let's look at JEP 244 next. So JEP 244 is about the most important, I think, network security protocol, TLS. TLS drives the heart of the world, right? Every major secure website uses TLS. Is your cat website TLS yet?
No.
Not yet? I'll wait. I can wait. Let's go. Let's do it. Let's encrypt the Mozilla TLS configuration guideline. There's a free certificate, quick and dirty configuration. We can get this done in like 10 minutes. Let's do it. You ready? Laptop up. No, Jim. No. Okay, all right. Jeff,
It's not live there yet.
I'm going to tell you just once, I was giving a talk to an audience like this. I talked about it, and the gentleman popped open his laptop and started working on it. By the end of the talk, he had HTTPS running. I'm just saying. All right, JEP 244. This is TLS application layer protocol, the negotiation extension. So in order to support TLS clients and servers who wish to use multiple application protocols over the same transport layer port, the ALPN extension, ALPN, allows a client to provide a list of application layer protocols it supports in the order of preference. A server can then select one of the advertised client protocols and tell the client which protocol will be used for TLS connections. So if you're a very cheap bastard like I am, and you want one server to handle many websites and many standards, this will help you do it. Moving on. So, JEP 249, yeah, Java Enhancement Proposal. How did these happen? Somebody like you was like, Java is terrible. There's no Datagram security, this is terrible, and they made a JEP and pushed it through to make it happen. So you can do the same. JEP 249, I love this. This is OCSP Stapling for TLS. So what is OCSP Stapling? It's all about revocation for Java certificates. When you have a certificate, there have been examples where certificates have gone bad, where people have done bad things as an authority and they were forced to revoke a certain certificate. We want that to trickle across the whole net. And that's what OCSP stapling is. And, it takes like 10 days for this revocation information to fully propagate throughout the net. We want to do better. Browsers tend to have a soft fail policy, which often makes revocation ineffective. And OCSP requests can be intercepted and modified. We'll look at this a little bit later as well. When we check the revocation status of an X509 certificate, it is critical part of a valid certificate-based authentication. Remember, TLS runs the world. Every major website or web service that all of us are working on depends on TLS for the most basic aspects of security. We need revocation to work well for this PKI system to survive in the world. But because of all the additional network requests, enabling OCSP, this is certificate revocation for TLS on the client side, can have a really significant impact. Because a lot of people want this revocation to happen at the browser level. It's not the best place to have it work. So OCSP stapling allows the presenter of the certificate, rather than their certificate authority, to pair the cost of providing these responses. And when it comes to TLS, it's the responsibility of the TLS server to request the OCSP response and send it to the clients during the TLS handshake. This also allows the server to cache OCSP responses and then supply them to all clients that are connected to it. This reduces the load on OCSP responders, since a response can be cached and refreshed rather than having this be done by each and every browser or client. So most browsers are going to ignore this information as well, except for EV certificates. So let's look at this. The Online Certificate Status Protocol is created as an alternative to certificate revocation list, the old school revocation CRL, certificate revocation list. It uses a lot less bandwidth. According to GoDaddy, their CRL, their certificate revocation list, grew from 158K in 2007 to 41 megabytes in 2013. So there's ways to get around that, but it still shows you the problem. When an SSL client encounters a cert that contains OCSP information, it contacts the designated OCSP server. What am I doing here? Yeah, it contacts the designated OCSP server to determine if the cert has been revoked. The key that signs a response needs not be the same key that signed, and this is all sent over HTTP. And one issue with OCSP is privacy, because the client needs to ask the CA for OCSP information. So my browser, in my mobile app, I make a request over port 80 to request the status for the web server. Port 80 to the client, the status is okay, and they sign this by your responder. No privacy when you do it that way. This is a bad idea. Privacy matters. And so OCSP used to include a nonce, but this doesn't scale well when caching and CDNs became the norm. As a result, clients don't send the nonce if the servers ignore them. For this reason, OCSP can be vulnerable to an attack called a replay attack, where a signed good response is captured by a malicious intermediary and replayed to the client at a later date after the certificate may have been revoked. The only defense is a built-in time limit. So the app talks to server and to port 80 to the OCSP request status for the web server. Great. There's port 80 to client status. Okay, signed by the responder. This is someone in the middle trying to shut this whole thing down, shut down revocation, and replay it. When an SSL client encounters a cert that contains OCSP information, it contacts the designated OCSP server to determine if the cert's been revoked. Because man-in-the-middle can suppress all the traffic to the server, this method's going to fail. Browsers tend to fail quietly in this case. Browsers can be configured to fail in a more aggressive way. In Firefox, you can go to your config and set security OCSP required to true, and it gives you a little more beef in your security if that's what you care about, right? So what am I trying to show you here? One sec. Let me take a step back. There we go. So the app talks to server, port 80 OCSP request status for web server. The server who's man the middle between your browser and the OCS responder captures that and can replay it when they wish to. The certificate authority does the usual thing here. It does the normal verification that this is the right website. It's going to move on here. To overcome performance, privacy, and security issues, the OCSP Stapling protocol was created. The web server is the one to talk to the OCSP server and obtain a fresh response. In fact, back over here, man the middle, it's HTTP. There's no security. I can change your cats to dogs if I wanted to. And no user would even know. So the man in the middle here is able to intercept the check if the certificate is revoked. It can fake an answer and denial of service to certain sites you care about. It's just there's no security involved here. It makes no sense. It's an HTTP protocol. So there's a better way to do this. And this is why Java supporting this is so important. Right here. To overcome performance, privacy, and security problems, OCSP Stapling was created. The web server is the one to talk to the CA and obtain a fresh response. The server can then cache the info and submit it to the client with the cert. Besides privacy, this improves performance, resolves man-the-middle drop package attacks that we've seen against OCSP. Apache supports this starting with Apache 2.4x, right? We talk directly, we get the answer directly, and we're done. So this is let's move beyond stapling. For the first time, Java is supporting this well. Your Tomcat Java servers now have this advanced capacity. It's a relatively obscure but important aspect to server-side security if that's what you care about. Let's look at JEP 287 next. So finally, we have SHA-3 in Java. The initial versions of SHA-3 in Java. What is SHA? What is SHA-3? What kind of algorithm is this? It's a hashing algorithm. And the hashes are not just important by themselves. A good hashing algorithm, like SHA-3 or Whirlpool even for some folks, the whole benefit of a good hashing algorithm is it drives many other kinds of cryptography protocols. For HMAX, for PBKDF2 for password storage, SHA and other hashing algorithms are the core for many other important areas of cryptography. So first of all, here's the non-goals. The non-goal is this JEP will not implement, if you're anybody here into crypto, 2, 3, okay, great. This is for you. This JEP is not going to implement SHA-128 or SHA-256 extendable output functions. They're not approved yet as formal hash functions. The latest standard does not contain a SHA-3 support yet. Thus, there's no change to the Sun PKCS11 provider. Also, this JEP will not implement SHA-3 based algorithms for other functions like signatures, max, and ciphers yet, since there's no standard. But this gives us a step in the right direction there. Those will be covered in future enhancements or JEPs, but we need to get SHA-3 working, step 1. So, SHA-2, would anybody know when SHA-2 was published? It's like 10 years ago. This is old. And although no significant attacks on SHA-2 has been demonstrated, NIST, the NIST organization, we all love and trust NIST, of course, NIST perceived a need for a dissimilar cryptographic hash function as an alternative to SHA-2. So now we have SHA-3 showing up, no new APIs available. It's just there for in the proper providers. This is going to be the foundation for future strong cryptography, which we desperately need in many kinds of Java applications. Let's look at JEF 288, right? JEF 288, I love TLS. We get 3 major benefits when you're doing TLS. We get confidentiality. That means the spy on your network, they can't see your data. We get integrity. The spy on your network can't modify your data. And also, you get authenticity. The server you're visiting is the right one. This is backed up by the certificate authority system. This is fundamental to building secure websites and web services. So, when we have a TLS certificate, this is how your web server is built. So when a user visits your website, they know they're visiting the correct website. You set up your website, you build a public-private key on your website, that's going to drive HTTPS. You take your public key to an authority, and they will sign your public key and give it back to you. Now you have a public key on your website or web service that's been signed by the private key of a real authority. And if you look in the Java client, if you look in any of your browsers, you have a list of every public key of every major authority, and that's built into all the user agents. Whether it's a Java user agent, whether it's a browser or a mobile app, they all have the public keys of all authorities. This is what binds the security of the web together today. Even though it has some problems, well, another time, right? And so many of the certificates that we use today are signed by SHA-1 in some way. The use of SHA-1 based digital signatures is a huge security concern because of collision attacks. NIST recommends in SP 857 Part 1, that SHA-1 should no longer be used for digital signatures. We've known about this weakness for years. And what Java is doing is they are fully shutting down any certificate chain that uses SHA-1. This is a very aggressive move, and it's a good move, I dare say, because we care about the authenticity of the web. We care about the security of the web. If this completely falls apart, the whole web falls apart. And Java drives the web in many ways today, right? And the urgency to move on is dramatic. In 2012, it cost like a little over $2 million worth of hardware computing resources to crack a signature, to fake it out in some way. And as Moore's law gives us faster and faster computers, In 2016, the cost to crack a SHA-1 certificate is 700 grand, less. And as time goes on, and as computing power gets stronger, in a matter of under a decade, SHA-1 is gonna be very cheap to fake out. So you see all the major browsers forcing SHA-1 out of the browser. Here's an example of Google, right? Google is in September 2014. Any cert that expires in January of 2007 with SHA-1, they would get the yellow triangle of doom. You see that? Terrible yellow triangle. And in November of 2014, Chrome 40, certs that expire between June of 2016 and December 2016 using SHA in the chain, they'll get the white document of insecurity, right? And in Q1 2016, if you have a cert that expires on or after January 2017 with SHA-1, you get the red X of doom and the red line of doom. Can you imagine me trying to go to your cat website and I get that red X? That would hurt. That would be painful for me. I don't know if I can trust your cats anymore. I'm just saying. Right? And so Mozilla agrees with this, right? Mozilla is in the process of doing the same basic thing within the Mozilla browser. Let me move on. There's a neat website called SHA.com, which you can plug your site into to check if you have an out-of-date signature with SHA-1 in the signature, so you can make sure, give yourself an easy check that tells you need to update your website's HTTPS. Just a quick, so it's SHA.1. So this is, anyways, let's moving on. A quick crypto note. If crypto APIs are important to you over time, who cares about crypto? Who's big into crypto? 1, 2, 3, 4, 5. A few of you. Take a look at the Java cryptographic roadmap. This will help you keep an eye on any planned changes, at least in the Oracle JRE. There's a link to it. This is extremely well maintained. It was updated just a few days ago, right? Also, take a look a few days ago as of Java 1 from a few months ago. Not sure now. But take a look at all the major crypto changes that happened in Java 8 alone. This is one of the largest moves in supporting modern crypto in the history of Java, right? We now move to, again, in the US, we move to a stronger suite of cryptography for US applications, right? We have stronger ephemeral cipher suites to stop like nation state level attacks and better random number support. This is great. How do we do good random numbers in Java? What class gives us good random values in Java? Right, Java.secure random. But how do you know if you're using the strongest provider underneath secure random? That was kind of you had to make a guess at it. So there are new APIs in the random classes that will say, give me the strongest random number available as an API call, and Java will make the decision for you. That's a good idea. It makes it even easier on you as a developer to get a good random number, right? So I know I'm sorry to scare you with crypto on a Thursday night, but let's talk about the plugin free web for a bit, right? The Java 9 web plugin will be deprecated in Java 9. It needs to go, right? We need a plugin free web. In fact, one of the recommendations we make if you're a simple user of the web, turn off Java applets. And I mean no disrespect to Java, but Java is not meant to be an applet technology. It's not. They've done a really bad job at maintaining the security, and even though they've gotten better, we want the whole web to be standard, right? We want Adobe Flash to go away. We want applets to go away. We want anything that's not native to the browser to go away so we can have a secure web. And this is the trend, right? How many websites still depend upon Flash? Even though that's significant, we see a lot of the top major video sites dumping Flash to HTML5 video. This trend should continue. Those of us doing development, I believe that we should be moving away from applet development more towards using better standards within the web. Java rules the server, don't get me wrong. Java rules for server-side programming and some of the most heavily hit websites on the planet. You know, Twitter was using, when Twitter, one of the most heavily hit services in the world right now, Twitter began its life as a Ruby on Rails application. Anybody here do Ruby on Rails development? How scalable is Ruby on Rails these days for millions of users? It's not. It's very poor for that use. So Twitter they ended up forking the core of Ruby on Rails to support early years, and they gave up, and they're now a Scala shop, a JVM Scala application. So Java technology runs some of the most heavily hit services on the planet. It's time to get rid of Java out of the client, in my opinion. So the plugin will be deprecated in Java 9, which means it will still be there for compatibility, but discouraged and scheduled for actual removal, possibly in Java 10. Also, real stats show a huge drop in Java plugin attacks before we did this. But since the Java community under Milton Smith, who ran Java security team last year or about a year ago, fixed tons and tons of things. So even though it's gotten better from a security point of view, Java 9's making a wise choice. Get rid of Java plugins, get rid of the Java web plugin, and consider moving away from Java in general as a web applet technology, right? So here's a few for the Java security analysis tool geeks, right? There's suddenly now a bunch of easier ways to dig into the depths of Java if you want a tool that's going to analyze the security of Java. Any of you use things like static analysis engines in your work at all? Use any tools that scan your Java looking for security? I'm sorry? It's a free start, right? It's free. I'm not trying to sell I'm not trying to sell anything, but for a lot of the companies I work for a lot of banks and stuff like that. They use different tools to scan Java every day, every check-in, looking for security bugs before it gets pushed live. These are called SAS tools, right? Static Analysis Security Testing tools. And they're very limited in the past of how much they can dig deep into Java. So there's all these new Java, making Java security great again. Sorry about that. I was joking around. Believe me, it's going to be huge. I did this before he got elected president. So hang on for a sec. Hang on. Let's just do that. And you're out. Sorry. There we go. Sorry about that. This is from Java 1. And I was like, there's no way he's going to be president. Come on, he's an idiot. And like, oh, wow. Whoa. Holy cow, what a few months makes, right? Let's take a moment of silence. Okay, good. So let's make it easier to look at security problems in Java. We have JEP 236. This is the parser API for Nashorn. This is awesome. We now have a full JavaScript compiler built natively into Java. Yeah, that's crazy and awesome. And so as a security professional, it lets me do a lot of interesting things deep in Java. So that aside, we have JEP 190. This allows me to have a pluggable static analysis engine deep within Java. So it makes it incredibly easy. It's a whole framework in conjunction with type annotations allow us to define extensions that perform static analysis at compile time. So now I can begin to enhance the Java C compiler, put my security checks, so every time I start to compile Java, I can begin to run a bunch of security checks. For a security geek, security professional, this is a big deal. And again, I'm just a consultant. Those of you, who's building Java applications, most of you here, you care about security? Do you? Maybe. Do you care about, you're like, whatever. Seriously, is security something that comes up in your world at all? More and more so? Maybe? And so I think you should consider static analysis, right? Use find bugs. Use a free version of it just to get started. It will help you catch security bugs before you push code. I digress. There's also JEP 243. It's a Java level JVM compiler interface. Now I can use Java code to talk to the Java compiler. See, Java C used to have only a few switches. They had more and more, and now I can literally use an API to talk to the compiler from a security tool point of view. Big deal. Okay, next. This you actually may care about this one. So, okay, you may care. Java modularity. This is the main reason why Java 9 has been heavily delayed, because the main reason Java 9 delayed is because of Jigsaw. This is the ability to modulize the JVM and only run certain parts of the JVM. We've had this for a while, right? We've had this for a while where, first of all, the goal is if I am pushing less of the JVM to the server, the attack surface decreases. My ability as an attacker or a hacker to go after your application is reduced as you use less of the JVM. And funny thing is the Java has made it easy for you to remove all applet technology out of your server code since like 2013, right? You can run Java in server or client mode, and when you run your Java in server mode, you're literally taking all the applet APIs and all of the client APIs that a server application doesn't need and removing them from your JVM. It makes it harder for me to attack you. And so the savings that we see here are pretty dramatic. So this is just Java 8 now, right? Java embedded 8. The regular JRE in Java 8 is 163 megabytes. When we remove graphics, Corba, and sound, you're not going to use graphics or sound in your application. And if you're using Corba, that means you're an old man like me. That's okay. Anyone using Corba? Anyone using Corba? Okay. Long time ago. Okay, good. Corba is pretty much out. There's a lot of problems with Corba, so you can just turn this off if you want to, right? And if you remove Kerberos, that's Microsoft technology, and JMX monitoring, 15 megabytes go away. Then you get rid of JDEC and XML if you want to. 11 megabytes go away. So now we've had these technologies for a while, but Java 9 is going to amp it up. So Java 9 is going to replace the whole class path mechanism. In Java 9, class path goes away. Wait for applause. How many hours of your life have you spent fiddling with the Java class path? I measured it, for me it was about 300 hours. I've been writing Java since 1997, Java 1.0.2 on Netscape 3, building Java applets at GE back in 1997. So I've spent, over the course of my career, at least 300 hours of my time fiddling with the class path for different projects. Does this sound familiar? And Java 9, what happens to the class path? It goes away. They're going to use strong encapsulation to allow a component to declare which of the public types are accessible to other components. It's going to radically decrease the size of your programs. It's going to reduce the attack surface as features you're not using go away. And so if you look at the module summary here in this URL, there are 72 levels of modularity that you can remove from your JVM. This is a big deal, right? This is a big deal from both a usability point of view, just those who are trying to build Java, as well as it's a big deal from a security point of view, as it reduces the surface for attacks against your application. I think something, again, you may care about this too. In Java 8, we have all the benefits to annotations. Java. What version of Java are you all on now? Who's still on Java 4? Java 5? Java 6? End of life about 4 years ago. Java 7? Java 7? Java 8? Most? Well, half? So don't get me wrong. I do. A lot of us are depending on versions of Java that were end of life like years ago, right? Many years ago, and there's no more patches available for them ever again, right? It's a world we live in. It's just, you may want to move to Java 8. You may want to bump that up to Java 8, right? Ideally. Anyways. So Java 8 gives us all these changes to annotations. We have type annotations that lets developers produce better code, improve accuracy of automated code analysis. We got the checker framework from the University of Washington that allows for type annotations even as early as Java 4. So if you're using really old Java, you can still plug type annotations into Java 4 applications. I think type annotations are a big deal if you're trying to write secure code. It adds a lot of robust features into your code. For example, I can use the override annotation that allows the compiler to immediately determine if developer wrote the wrong method signature instantly. Other annotations like non-null and read-only, they can be used for analyzers like the checker framework, FindBugs, Eclipse, NetBeans, IntelliJ, or other commercial analyzers. These analyzers can be run at compile time through IDE background compilation, through Maven or Ant, or continuous integration like Jenkins. Type annotations tell those analyzers what to look for. Without type annotations in place, these analyzers would still be able to locate null, usage, and write modifications, but would not know if they were wrong or not. The result would be false negatives. So, again, my world is security. I'm a Java security person. I write books on Java security. This is all super exciting and important to me. Yay! Okay. And so, we also have the whole idea of an annotation validation versus business validation, right? Type annotations are best used with common forms of validation that relate to computer science. These are certain types of business validation that's not going to work within an annotation. So things like null value checks, numeric range checks, basic type checks, assignments and updates, data flow validation detection, and so on. Let's move on here. So this little chunk of code makes it clear that the return value string is modifiable by a user. We're saying that this is tainted. That it's obvious that it's tainted. That means that as a programmer, this could be any value, and this is how attacks enter your software through request data like this. So a tainted or untrusted value is one that comes from an arbitrary, potentially dangerous source, like user input or unvalidated data. In certain parts of your application, using a tainted value can compromise the entire application security, making it crash, stealing data, and so on. If the tainting checker issues no warning for a given program, then no tainted value flows to a dangerous part in your application. This is formally in computer science called taint tracking. As a simple example, you might have forgotten to annotate a sensitive sync as requiring safe data, or you might have forgotten to annotate untrusted data as having a tainted type. So this is great for secure programming, because if I label like my SQL, my LDAP, and any other dangerous use of data, then at compile time, I'll be warned that I have just coded a security error, and that request data can flow into these dangerous syncs. This is a great idea for compile time security checking, right? Here we have, and then each command must be untainted. What I'm saying here is, you're going to run some commands. I'm going to hit some kind of operating system level command, and it must be untainted. I'm specifying that no untrusted data or request data is allowed to flow into this function, and if it does, I'm gonna make a compile time error. This is great. This will stop SQL injection attacks. This will pretty much stop any forms of injection where untrusted data can change your commands. So it's all about the little things. Andy Warhol said, You need to let the little things that would ordinarily bore you suddenly thrill you. That's like the heart of this talk, right? These are all these little security and cryptography things that for me are thrilling, and for you as a developer, as you go through your career, as security becomes in your face more and more and more, I hope that these little things matter because they're really bigger than they appear. Much of the real work that has a big impact on the world is seemingly boring stuff. Look up the work of Joe Darcy. Joe Darcy is one of the core Java developers, really smart and humble guy. He cleaned up, this is what his job was. He cleaned up thousands of bad lint warnings in the JDK. Anybody want that job? Sounds like it's boring, but how important is it to you as a developer? I think it's extremely important. It's done by suppress warnings or actually fixing the code. Take a look at this blog post, right? This blog post shows the effort it took just to make Java warnings more accurate in more recent versions of Java. Because, you know, for older versions, the warning messages are almost nonsensical in certain versions, in certain areas of Java. So he cleaned this up. And, you know, a little irrational exuberance goes a long way. When you spend time to remove the things that are not worth looking at, when you start removing all these little bugs within the JDK and JVM, it's easier to see the things that are important. You sweep the dust away, the things that really need effort become more apparent. And so again, it's boring work. It's work that doesn't get a lot of credit, but it's incredibly important to the future of the Java platform. And my final Hawaiian word is pow. That means we're done, or it means it's finished, complete. A very common Hawaiian word. We say, hey, you got any more work to do today, bro? No, I'm pow for the day, man. Let's have a drink. Okay, good. And so I want to say thank you to two people. Eric Koslow, who was the ex-product manager of the Java platform. He's looking for a gig. And Sean Mullen, who's the technical lead of Oracle's Java security library. It's a lot of thankless work, and really nice gentlemen who've helped push Java along. So what can you do? Create JEPs. For any enhancement you want to see in the JDK, create a Java enhancement process. Support the existing JEPs. They're all listed out. Maybe one of them matters to you. Help support it in some way. Also, check out the Quality Outreach Campaign. This helps open source groups handle feedback in case you want to send a message to the Java team. There's a few ways to send a note to the Java team. You can go on Twitter and complain. You can go on Facebook, complain. Or you can actually send a comment in the JEP process so the people who are really building Java can be influenced by what's important to you. They just listen to the squeaky wheels. The squeaky wheels get the grease, so it's okay to squeak. Also, a few things I want to point out. The output encoding library, if you're trying to stop cross-site scripting in Java applications, there's only one good library that does escaping, that stops cross-site scripting, and that's the OWASP Java Encoder project. Fantastic. Also, for really advanced access control, I've been analyzing a project called OAK, the OACC project. It does heavy lifting, but if you're looking for advanced access control, this is a good thing to study. A few other cool things are these are things I'd like to see. Let me explain this slide. These are things I personally would like to see in Java. I'd like to see an escaping library for cross-site scripting. I'd like to see better content security support in Java EE for the web. I'd like to see Java has awful access control. Role-based access control is an anti-pattern that we should stop using. We need something like attribute-based access control. And here's a project called Oak, which it may help enhance Java someday. We need more automatic built-in Java security so you don't have to worry about it anymore. I also like the idea of having a safe string class so I can flush data out of the JVM like a password or a credit card. I can't do that right now. I have to wait for the garbage collector to make that decision for me. And you really can't tell the garbage collector what to do, right? You have to be nice to it and hope it will remove it when it feels like. That's how marriage works too. Okay. Ahui ho. This ahui ho is my final Hawaiian word. It means goodbye until we meet again. So ahui ho, Java community. Thank you for being here. Have a nice day. Any questions? All right. If you have questions for me, I'm jim@manicode.com. Have a great night, everyone. Thank you so much.
Maybe if you have a question for the audience, if you know, to give away the intelligent license.
Bingo.
If you have something.
I do. What does Java OCSP Stapling do that improves it dramatically? Go ahead.
It refers the certification removal when the certificates are no more valid or trusted.
Perfect.
Excellent.
Thank you.
Want an intelligent license? Thank you. Just to finish, we have the